Hello everyone and welcome to IP study lecture video. Today I am going to take chapter number 9 of grade 7 and the name of the chapter is Lines and Angles. So dear student, without wasting our time, let's see what are the topics that we are going to cover in this video. First of all, we will see the definition of angles. Then we will study about pairs of related angle. Next, we will discuss about parallel and transversal line. Thereafter, we will discuss about the angles formed by a transversal with parallel lines, and towards the end of the session, we will be discussing about the properties of the angles that are formed by parallel lines and a transversal. So let's start the lesson. So first of all, let's discuss about what are angles. So the basic geometrical terms we have already discussed in our previous classes, like what are points, what is a line, what is a line segment, what are rays, right? So let's discuss about what are angles first. So dear students, let me show you over here an example. Can you see this? So here this is an example of an angle. So what are angles? When the two rays meet at a common point, the inclination between these two rays is called an angle. And these two rays meet at a common point, I've said. So this common point is called the vertex. Am I clear to you? So what is an angle? An angle is an inclination part that is formed between the two rays which are joined at a common point which we call a vertex. So let's move forward and let's see what are the different topics we are going to cover in this. So let's discuss with pairs of related angles. The first one is adjacent angles. So what are these adjacent angles? So let me take an example to describe you what are adjacent angles. So dear student, can you see this figure? Here we have three rays, ray X, ray Z and ray Y. These three rays are connecting at a common point, that is O. And I told you the common point is called the vertex, right? Now we can see two angles over here, this one and this one. Let's say this is angle 1 and let's say this is angle 2. So what is common between these two angles? The first one is ray OZ, right? This one. This ray OZ is common between these two angles and this vertex is also common between these two angles. So there are two conditions for the angles to be adjacent. First of all, when the two angles have common vertex and when the two angles have common arm, then the two angles are said to be adjacent angles. So here angle 1 and angle 2 are adjacent because they have a common vertex O and they have a common arm, that is OZ, right? So these are adjacent angles. Now let's discuss the second pair of related angle, that is linear pair. So in this case, students, when the two arms of an angle are totally opposite to each other in such a way that they are making a straight line. So let's take an example over here. We have BOA, right? We have one ray this side, one ray this side, they are just opposite to each other. And we have another ray falling on this straight line making two angles. Let's say angle 1 and angle 2. So it is a case of adjacent angle, right? How come? We have a common vertex O over here, right? And we have a common arm over here, that is OC, between angle 1 and angle 2. So are linear pair adjacent angles? Yes. Linear pair are adjacent angles. Now what is the speciality about this pair of adjacent angle? The speciality is the sum of these two angles, angle 1 and angle 2, is always equal to 180 degree. Why it is so? Because here two rays are opposite in such a way that they are making a straight line, and we know that in a straight line the sum of the angles is equals to 180 degree. Am I clear to you? Now let's move on to the next type of pair of related angles, that is vertically opposite angles. So here students, we will discuss about intersecting lines. Why? Because when the two lines intersect each other, they also form angles between them, right? So let me show an example over here. Suppose I have these two intersecting lines, right? So how many angles are formed over here? I can see 4 angles. Let's name them. Let's say this is angle 1. Let's say this is angle 2. Let's say this is angle 3. And let's say this is angle 4. If I talk about angle 1 and angle 2, do they have any common arm? No, they don't have. It means they are not adjacent angles at all. Then these are opposite to each other, right? So since these are opposite to each other, we call them vertically opposite angles. Again, if you see angle 3 and angle 4, these two angles do not have a common arm, right? So again, they are not adjacent angles. Since they are opposite to each other, we call them vertically opposite angles. Am I clear to you, students? So let's move forward. Now let's see what is the next pair of related angles we have. Next we have complementary angle. What are complementary angles? The two angles are said to be complementary when the sum of these two angles is equivalent to 90 degree. Suppose I have pair of adjacent angles over here. Let's say this is angle A and this is angle B. So these angle A and angle B are said to be complement to each other if the sum of angle A and angle B is equals to 90 degrees. Am I clear, students? So this is all about complementary angles. Now let's move to the next type of angles we have. We have supplementary angles. So here, suppose I have again, let's say this is angle A and this is angle B. Angle A and angle B are such that the sum of the two angles is equals to 180 degree. Then these angles are called supplementary angle, or simply you can say that angle A is supplement of B or angle B is supplement of A, right? So these are the type of angles, type of pair of related angles that we have finished just now. Okay, so now whatever we have learned, whatever we have discussed so far, let's explore it with the help of an example. So let's take an example over here. Let's take example 2. Can you see this figure? Here, in this case, we are supposed to find the value of x. So now children, look here. We have a straight line EAB, and we have two rays, ray D and ray C, which are falling on this straight line at a common point A, right? Due to which we got three angles, angle AOD, angle DAC, angle CAB, right? Now we know that the sum of the angles on a straight line is always equals to 180 degree. So what we will do here, we will simply add all these angles. So what we will do, first of all, we have EAD equivalent to x plus 31 degree. So we will write x plus 31 degree. Next we have second angle, that is DAC, which is equivalent to x plus 20 degree. So we will write x plus 20 degree. Next we have CAB. This is equivalent to x. So we'll write x over here, right? Now the sum of all these angles will be equal to 180 degree because EAB is a straight line. So what we will have? We will have 3x plus 51 degree post addition equivalent to 180 degree, right? On solving it, you will get the value of x over here, that is 43 degree. Am I clear, student? I hope this example is very much clear to you. Now let's move on to the next example. Here in example number 3, we have to find out complement of the following angle. Now we have discussed what are complement angles. Complement angles are the angles whose sum is equivalent to 90 degree. So if I say you have an angle of 45 degree, suppose, and I ask you what is the complement of this angle? So what is the complement of this angle? You know that sum of the complementary angle is equals to 90 degree. So let's say the complement of 45 degree is A, suppose. So I will add 45 and A, which is equivalent to 90 degree according to definition of complementary angle. So what you will get? If you transpose it, so 90 degree minus 45 degree, so what you will get? You will get 45 degree. it means that the complement of angle 45 degree will be 45 degree. Am I clear to you? Now let's take one more example for this. Suppose you have an angle of 30 degree. Okay. Now I will ask you, what is the complement of this angle 30 degree? What you will do? Let's say the complement of this 30 degree is A. So you will write A plus 30 degree is equals to 90 degree according to the definition of complementary angle. When you solve this, what you will get? You will get 90 degree minus 30 degree, which is equivalent to 60 degree, right? So what is the complement of angle A? The complement of angle A will be 60 degree, right? And what was your angle A? Angle A was 30 degree. Am I clear to you? Now let's move forward and see what is the next topic. So here we have parallel lines, right? So we have already discussed about this topic in the previous grade as well. So what are parallel lines? Parallel lines are the lines that never meet each other, and the distance between the two lines always remains constant, right? Suppose, have you seen railway track? So what are railway tracks look like? They looks like parallel line only. They never meet, right? And the perpendicular distance between two lines always remains constant. So these type of lines are called parallel lines, right? Next we have a transversal. What is a transversal? A transversal is also another type of line which intersects parallel line, two or more than two parallel lines at distinct points. So here if I say this is parallel line A, this is B, this is C, then M will be a transversal line because this transversal line is cutting these parallel lines at distant places, at distant point. Let's say this is X, this is Y, this is Z. So this transversal line is cutting these parallel lines at different points, right? So let's move forward. So dear student, whenever a transversal line cuts two or more parallel lines, different angles are formed, right? So let's explore what are the different angles we have whenever a transversal line cuts parallel lines. Okay, so here suppose I have these two parallel lines. Let's say this is L, this is M, okay, and we have this transversal line. Let's say this is N. This is cutting these two lines at these 2 points, right? So how many angles we have? Let's say this is angle 1, this is angle 2, 3, 4. Then we have this is 5, 6, 7 and 8, right? So we got 8 angles over here when a pair of line is cut by a transversal. Now let's explore what are these angles called. So let me take another color. So let's explore these angles. First of all, can you see this angle 1, angle 2, angle 7 and angle 8 outside the parallel lines? They are not between the parallel lines. So we call these angles as external angles. These are external angles, right? Now let me take another color. Can you see this? Angle 3, angle 4, angle 5 and angle 6. As these angles are formed between these two parallel lines, we call them internal angles. So we got external angles, we got internal angles whenever a pair of line is cut by a transversal at different points, right? Now we have some more angles. Let's explore them. Okay, and we name them L, we name them M, and the transversal was N, right? 1, 2, 3, 4, 5, 6, 7 and 8. Now students, the angles which are formed on the same side of the transversal, they are called corresponding angles, in which one angle will be outside the parallel lines and one will be between the parallel lines. Let me show it over here. So let me take a red color for this. So can you see this? Angle 2 and angle 6. They are on the same side of the transversal, right? Angle 2 and angle 6. Similarly, angle 1 and angle 5. They are also on the same side of the transversal, right? In the same way, angle 4, angle 8. They are on the same side of the transversal. In the same way, angle 3 and angle 7. They are also on the same side of the transversal. So we call them corresponding angles. These are corresponding angles, right? Now let's move on and let's see what are the other angles that we can see whenever a parallel line is cut by a transversal. So students, suppose we have this parallel line, again we have this transversal over here. So beside these angles we have some more angles. See, can you see these two angles? Here this is angle 2 and this is angle 7. This is called alternate exterior angle. They are on the opposite side of the transversal and exterior, right? Outside the parallel lines. So we call them alternate exterior angles. In the same way, if we take these angles, can you see this? This one. This is angle 4 and this is angle 5, right? So these are called alternate interior angles. These are alternate interior angles and these blue ones are alternate exterior angles. So students, we have studied about different types of angles that are formed by a pair of parallel lines when they are cut by a transversal at distant point. Now let's discuss about the properties of these angles. So the property first says that whatever pair of corresponding angles are formed, they are always equal, which means that we have this 2, 6, 4, 8 on the same side of this transversal. It means that these are corresponding angles. So we can say that angle 2 is equals to angle 6, right? And angle 4 is equals to angle 8 because they are corresponding angles. In the same way, angle 1 will be equal to angle 5 and angle 3 will be equal to angle 7. Why? Because they are corresponding angles. So whenever a pair of parallel line is intersected by a transversal or cut by a transversal at distant point, we say that the corresponding angles so formed are equal. Secondly, the pair of alternate angles are equal. So we have just discussed like angle 2 and angle 7, they are alternate exterior angle, and angle 4 and angle 5 are alternate interior angles. So these angles are also equal. So whenever a parallel line is intersected or cut by a transversal at two different points, then the alternate exterior angle and alternate interior angle will always be equal. Now let's see what the third property said. The third property said that the properties of interior angles on the same side of a transversal are supplementary. It means that suppose you have this parallel line L and M cut by a transversal N at different points. Then the sum of these two interior angles, let's say this is 1, let's say this is 2. So the sum of angle 1 and angle 2 will always be equal to 180 degree. They are supplementary. So whenever two parallel lines are intersected by a transversal, the sum of the interior angle will always be equal to 180 degree, right? Now let's move on to the next property, that is pair of exterior angles on the same side of a transversal are supplementary. Okay, this is similar to the property that we have discussed just now. The only thing is we have considered interior opposite angles, we will take exterior angles, right? So students, we have discussed the properties of different angles formed by a parallel line cut by a transversal. So let me quickly summarize the points that we have discussed in this video. First of all, we have discussed what are angles. Angles are the inclination area formed between the two rays which have a common vertex, right? We called it angles. Next, we have discussed different pairs of related angles, like what are adjacent angles, what are linear pair, what are vertically opposite angles, what are complementary angle, what are supplementary angle. Then we saw what are different types of lines we have. The one is parallel line, the second one is transversal line. Then we have discussed what happens if a pair of parallel line is intersected by a transversal line at different places. At the end, we saw what are the angles formed by a parallel line by a transversal, right? So I hope these topics are clear to you. So that's all for the today's session. Next time we will meet you soon. Till then, take good care of yourself. Keep learning, keep practicing. Thank you.